In the next 5 minutes, we'll review the core elements of JIT's open ASPM platform, which makes 13 different code and cloud security scanners feel like one and empowers developers to secure everything they code. Let's start in JIT's security plans. Each security plan contains the product security tooling, integrations, and reporting needed to drive your organization toward a specific business objective, which aligns different teams around a shared outcome. Take the SOC 2 plan, for example, which contains the product security controls needed for SOC 2 compliance and can be implemented across teams in a few clicks. In JIT's Max Security Plan, we can see all of JIT's scanners, including SAST, SCA, and secrets detection for AppSec. For cloud security, we can activate infrastructure as code scanning, CSPM, Docker file scanning, and Kubernetes scanning. And finally, we see the options to implement DAST for our web apps and APIs, and CI/CD scanning to surface GitHub misconfigurations. Activating the code scanners will analyze your entire code base for existing vulnerabilities, while implementing continuous security for developers by scanning every code change. Let's check out the developer user experience. Developers can easily adopt JIT because they don't need to leave their environment or be security experts to consistently resolve security issues. While this example is in GitHub, developers get the same experience in their IDE and GitLab as well. In this example, JIT's change-based scanning automatically detected a security issue in a pull request I just created with JavaScript code. As we scroll up, JIT's description tells us that this issue could lead to cross-site scripting vulnerabilities. Rather than investigating the issue in a different interface, JIT provides suggested guidelines and auto-remediation within the PR so we can resolve the issue in a click. To reduce false positives and explain the impact of the issue, JIT also tells us the runtime context of our code. It looks like this code introduces a vulnerability to our production environment that will be externally accessible. To dig deeper, we can scroll up to get additional information into the runtime context of our code, which tells us that this repository calls a sensitive database. We're getting all this information from JIT's knowledge graph, which describes how this repository is deployed in runtime by mapping our code pipeline and cloud environment. Developers need this context to understand why a given security issue really matters, so they know to make the fix before deploying their code to production. While developers prefer an integrated experience in their environment, security teams need a consolidated view of unresolved security vulnerabilities across scanners, which we can see here. JIT's context engine prioritizes this backlog by assigning a priority score to each issue based on its runtime and business context. We can see how JIT determined the priority score and investigate the issue by opening it up and expanding the knowledge graph. Like we just saw in GitHub, the knowledge graph shows us how and where the code that contains the security issue is deployed and which services it interacts with, so we can understand the real impact of the issue. In this case, we can see that the issue we selected is rated as high severity and has a fix available. It resides in code that calls a sensitive database, which is running in our production environment and is externally accessible to the internet. JIT's Wiz integration is also showing that Wiz detected an issue in this repository. This knowledge graph is generated automatically for every security issue after you integrate JIT with your AWS or GCP account. In this case, we clearly have a serious issue, so we can act on it by creating a fix PR with JIT's suggested code fix, or by triaging the issue through Jira, Slack, Shortcut, Linear, or Monday. While this perspective is great for security teams that need a consolidated view of the top risks, development teams will need a dedicated view to focus on the security of their services. In JIT teams, we can see an overview of all our development teams and the security score of the services they own. As we click on a team, we can see their dedicated portal that shows the security scores for all their code repositories, which are based on the risk that unresolved vulnerabilities introduce. These scores are aggregated into the team score, which can be monitored over time to measure progress and setbacks. We can hit top findings to view a prioritized list of the riskiest security issues across this team's services. Or we can click into a specific resource, which shows us the scanners that detected security issues and a prioritized list of security issues in this resource so we can quickly triage the top risks. These are the core components of JIT, but there is much more to explore. Try it yourself by starting a free trial and connecting JIT with GitHub or GitLab. You'll be able to start scanning your apps and cloud infrastructure in no time.